Thank you all for joining us on this rainy Santa Monica day. We have an amazing panel. Now, this is truly an out-of-this-world panel. And so my name is Shahin. I'm a partner at Lux Capital. We're a venture capital firm that's very fortunate to be invested in these three great companies, and I'll let the founders tell you more about them. But just quick background on Lux. We've been around for 25 years. We've funded over 300 companies across hardware, software, and healthcare. And we have $5 billion under management. Current fund's $1 billion. We cut checks from $100,000 to $100 million. Our focus tends to be seed and Series A. I'm an electrical engineer by training. I joined the firm 17 years ago. I've led investments in chips, rockets, satellites, driverless cars, robotics, and more. But I am the least interesting person on this panel. With that, I'll hand it over to Ian to tell you more about Apex.
Hey, everybody. It's great to be here. My name is Ian Cinnamon. I am the co-founder and CEO of a company called Apex. At Apex, we make what are known as satellite buses. So that is the core part of the satellite. That is not kind of the business end, which is the payload, but it's the part of the satellite that allows the payload to function in space, to look down at the Earth, to move around, to communicate, and so on. And we make all of these satellite buses at our facility here in Playa Vista, so please come visit. And the core thing that we do is try to deliver our satellite buses incredibly quickly to our customers, most of which are defense firms or US or allied nations. So excited to dig in a little bit more with you all.
Awesome. I'm Laura, and I am the CEO and co-founder of Epsilon 3. And we build space operational software. So what that means is if you look at the control room, pretty much any control room has a GUI that powers the data. And then aside from that is all of the operational decision-making that has to happen on a day-to-day basis. So we help power companies that are launching satellites, that have launch vehicles, that are building private space stations. We also, in the energy sector, have been supporting customers in fusion and fission, as well as customers in robotics and aviation. So really, any operational, complex engineering company can use something like Epsilon 3, and it's been helping them move faster and deliver products with smaller teams. And that's a little bit more about Epsilon 3.
Good afternoon, everybody. I'm Tom Mueller. I'm the CEO and founder of Impulse Space. A little bit about myself. I was a founding member of SpaceX back in 2002, and I led the development of the propulsion systems for the Falcon launch vehicles and the Dragon spacecraft, and led the development of the Merlin engine, the engine currently used on the Falcon 9, the most reliable rocket engine ever developed. About the last 5 or 6 years that I was at SpaceX, I worked on almost exclusively on Starship, a little bit of Starlink, but mostly Starship. And when I left SpaceX in about 2020, I decided that Starship was really going to provide transportation to low Earth orbit, but it was not really designed without refueling to provide transport to higher energy orbits. So I formed Impulse Space as a space transport company to transport things from low Earth orbit to everywhere else in the solar system. And we have two products right now. One is the Mira spacecraft, which I think I guess my video didn't roll. We have the Mira spacecraft. We have a couple of those on orbit right now. There it is. That has storable propellants, nitrous oxide and ethane, so it can stay on orbit for up to 5 years. And then we also have what I call the Get There product, which is Helios, which is basically a kick stage. It's like adding a third stage to Falcon 9 and other medium launch vehicles that allows Falcon 9 to do essentially what a Heavy can do. That is take like 4 tons of payload from LEO to GEO direct in one day, in about 12 hours. So that's what we're doing, and great to talk about it.
So you want to bring the mic a little bit closer to your, yeah. Awesome. So let's kick it off. McKinsey put out a number recently pegging the space market at roughly $1.3 trillion, and that's just a crazy number. But I thought that we would maybe unpack that a little bit today and kind of talk about how we measure the space market, because a lot of the excitement around this sector is driven by a lot of demand that's driven by geopolitical factors, driven by technology. And so maybe, Tom, we can start with you. When you were at SpaceX in the early days, how did you view the space market? What was the space market? How would you measure it? You were just talking about how SpaceX kind of only goes to a certain orbit, which was probably where people wanted to go back in the day. And now there's other orbits, other destinations that are interesting and have a lot of demand. So let's kind of talk about what that number was and what has led to that number absolutely ballooning to what it is today, and then we'll go down the panel.
Well, SpaceX is a launch vehicle company, or was back when we started it. And the launch vehicle, launch business is on the order, I think, of 5 to 10 billion, and it was less than that back then. But once they did Starlink, now it became, a hundreds of billion dollar addressable market. So where they started out was much smaller TAM than where it's at right now.
So Laura, back in the day, say 2000, nobody would even talk about software. If you were developing software, you were probably selling something on the internet or selling to the enterprise. Selling software into the aerospace ecosystem was unheard of. And now that's probably a pretty significant portion of that $1.3 trillion number. So maybe you can talk about your journey and observing this industry and where you see it going.
Yeah, I think when I started my career in space in 2004, so now you know how old I am, I worked at Northrop Grumman, and there were 5 different companies. There was Northrop, Raytheon, Boeing, Lockheed, and Aerospace Corporation. And some of them build hardware and some of them don't. But that being said, I worked there and at Northrop for 5 years, and there was not a startup ecosystem. There was government contracts and other government contracts. And there were no commercial space contracts. When I started at SpaceX in 2009, it was the only space company that was doing anything remotely commercialized. And SpaceX had this idea that the industry was going to grow, and we needed to address that market early and often. And I think we've all seen how that has gone. And when I left SpaceX in 2020, like Tom, I looked at the ecosystem that was basically booming from when I had started there in 2009 and realized that nobody was addressing the infrastructure problem or the software problem. Each company had to build and operate its own software stack. And that's not something that a 20-person company can do. You're looking at startups of 20, 50 people that didn't exist in 2004. And that has been growing exponentially since I started this company in 2021. And I think it's only going to get bigger, both on the commercial side and the government side, as we see the industry growing more and more over the next 10 years.
So Ian, if you would have asked me, even 10 years ago when I started doing space investing, whether a fledgling aerospace startup will have a third party build their buses, I would have said, no way. Everyone's fully vertical. They're playing the Elon playbook. So what happened? When did you observe this non-market for basically being a supplier into this supply chain that was pretty much non-existent? Everything was in-house. From the smallest company to the largest company, everything soup to nuts. I remember when I was touring Planet back in 2012, they were literally like soldering their own circuit boards. How did we get to this point where you saw this opportunity to become a kind of a tier 1 supplier of components? What's changed, and what opportunity does that present?
It's a great question. So if we take a little bit of a trip down memory lane, right? When the space industry started out, the first satellites went to orbit, 60, 70 years ago. There were not that many opportunities to get to space, right? Rockets were launching maybe once every few quarters at best. They were unreliable. They might not get to orbit. They might blow up on the launch pad, et cetera. And as things progressed, frankly, access to space got a little bit better, but there was really no major inflection point until, frankly, Tom brought everything together and really made SpaceX this dominant player that could not just reliably get people to orbit, but could do it at a cadence that was unheard of. So instead of having an opportunity to get to orbit maybe a few times a year, SpaceX is now launching nearly every single day. And as that has fundamentally changed, the result of that is if you're a company, whether you're somebody like Planet or whether you're a government or an allied nation looking to put a satellite into orbit, your mentality and your equation of what you're trying to do changes. So it used to be something where they were thinking, okay, if I can only get a launch opportunity a couple years from now, I am going to own every part of that to ensure that my satellite will work absolutely perfectly. I can't control the launch, but I'm going to control the payload, the satellite bus, every subcomponent, full vertical integration. But what changed was, as the cadence of access to space exponentially increased, the capabilities that people wanted to launch started changing. And what people realized was, you could now, the shipping cost to get from Earth to space went way down. And that meant the risk posture started to change. The business case started to change. People didn't want to launch one super expensive satellite. They wanted to launch dozens, hundreds, or thousands of satellites in a constellation. And as a result of that, companies realized they needed to specialize. So what companies started specializing in was the payload. They might be really good at developing a hyperspectral camera to look down at Earth, or really good at a focal plane array to track missiles as they come over the horizon. But those companies who specialized in those very particular areas, those areas are not satellite buses, right? They're not RF comms, they're not GNC attitude controls, et cetera. That's a fundamentally different set of skills. So what happened was these companies realized they could be really good at the payloads. They could try to invest heavily and go recreate the wheel and build buses. But if there was a reliable supplier who could get them their satellite bus, not just on time, but incredibly quickly, at an upfront and transparent price point, well, that was something that was frankly like too good to pass up. And that's, I think, a big chunk of the reason we've seen some incredible demand for our company. Look, we're barely over 2 years old. Our first satellite's been in orbit now, I could say today, over a year, still operating nominally. And we've built a massive backlog of other customers, and we're proud to see that growing now on a daily basis.
So a lot of investors here at the conference are, traditional software investors. And software investors look at what we're doing and they're saying, like, what? So you're soldering, circuit boards, you're welding, metal. Traditionally, these kinds of businesses, except obviously, Laura, for you, because you're a software company, but for Ian and Tom, like, people look at these companies and they think, okay, low margin, low growth, ultimately low multiples. Why should we be investing? Why should we pay the high multiple? But what you guys have ultimately proven is that you indeed can build a hardware-first company and generate software-like multiples, and not just that, but also create monopolistic effects where customers keep coming back to you, and you've created dominant kind of positions in your respective markets. So maybe if you can unpack that and kind of help the audience understand what's changed, what you've done differently recently that sets you apart from all these kind of frumpy old kind of like aerospace suppliers of yore. Tom, if you want to start.
Yeah, I mean, it all started at SpaceX, basically avoiding aerospace vendors like the plague, because just the way they do it won't scale cost-wise or efficiently. Become vertically integrated and set up production lines, like really the first company to have a production line to make rockets, to make like Starlink, to make spacecraft at a very high rate, where it's optimized for cost, not for performance. We're doing the same thing. We're trying to make a very like an orbital transfer vehicle that can do a lot of different missions, both commercial and government, and try to use the same pieces. Some of the things change, the antennas, the comms on them, but try to have the same chassis, the same propulsion system that fits everybody, and make it very reliable and make a lot of them.
So for our company, we're a little bit unique. I am the probably least typical aerospace founder you will ever meet, right? I am nowhere near as smart as Tom or Laura or Shahin, but I do come from a software background, right? Not an aerospace background at all. And what I will say is before I started Apex, right, I had the opportunity to run a different software company. I ended up selling that to Palantir. And what I realized while I was there was the #1 cause of anomalies for satellites on orbit was not hardware, but it was software. And software tends to be the most undervalued part of almost any aerospace company, right? There's, of course, some exceptions. And if you look at our team at Apex, right, our engineering team right now is about 1/3 software. We're scaling it up to about 50% software. People tend to think that it's all about the software on the satellite. But to Tom's point, it's so much more than that. It's the software that runs the entire company, right, which is why companies like Epsilon 3 that Laura founded and runs is like without that, like everything falls apart, right? You don't have a company. You're not able to manage. You can't build things at rate. You can't build things at scale. So I think this is just one of the most like forgotten about parts of the industry, but you have to really be software first. Use companies like Epsilon 3 in order to really scale manufacturing.
So Laura, a lot of investors here are traditional growth investors, and they look at Epsilon 3 and they say, wait a minute, you're selling to a bunch of rinky-dink, venture-funded, kind of like new space companies, but wait a minute, you're also selling to the primes and large established aerospace companies. So how do you pull that off? How does that work?
It's not easy. So I think for us when we started, it was, we're going to sell to all the startups. There's so many of them out there. And what we did was we started talking to people we knew, people we didn't know that were building companies that wanted to move as fast as possible. They had 20-person teams. But you can't build a huge business on, 5,000, 20-person teams if you want those teams to also be successful. So as we started scaling up the business, a lot of people nowadays, I tried to explain this to our team the other day, where 20 years ago, you would get a job at Northrop Grumman, and you stay at Northrop Grumman for 30+ years, and that would be your career. Nowadays, people will say, I want to work at this startup for 2 years. Once I hit this milestone, I'm going to go do something else, and they're switching jobs. So we get, a customer that's 20-person customer. That customer and their employees might change jobs, and sometimes they change to large enterprise customers. We got a lot of referrals into large-scale customers, and we started selling into enterprise-scale customers because of the fact that people love using our software, and they wanted to bring it with them to their new jobs. And so I think it started kind of with building from the ground up.
So there's 2 words in aerospace and defense that causes a lot of confusion and anxiety. Those 2 words are dual use. And so I'd love the panel to kind of help the audience understand, where does dual use work? Where does it not work? Where should it be embraced? Where should it be avoided? So maybe Tom, given the SpaceX experience, kick it off.
Dual use is something that our government customers ask us a lot. We're looking for dual use, which means we want to buy a commercial product that's already commercially developed, that maybe has a few changes to meet their needs, but it's mostly already a developed commercial product. And I think that fits in some instances, like depending on the technology, it fits quite well. Like in the case of SpaceX, it fit very well because there was basically a government spec called EELV, Evolved Expendable Launch Vehicles, that came out 20-some years ago, that sized the fairings, the EELV standard size fairing, the standard size payloads, and the standard size payload interfaces. And the government uses them and industry uses them. So it's already basically a dual use standard. So that made it pretty easy for SpaceX to be dual use and be able to sell to the largest customer in the world, which is, at the time was the Air Force, now the Space Force, and all the big commercial satellite operators. The same thing kind of goes to, like now we have rideshare, like the ESPA ring, and more recently SpaceX has developed the 4-point mount plate on their rideshares, which has kind of become a standard both for the government and for commercial use. So that makes it easy for a company like us to use that interface and be dual use. Like the Mira spacecraft was meant to be a commercial rideshare spacecraft, and we found out that there wasn't that much of a market for it, but our first one was very successful, and all of a sudden the government was very interested in that, so dual use worked great for us in that standpoint. But what we find is like the comms that you use, like you'll want encrypted comms and different frequencies, military bands and stuff. So as far as software and comm interfaces, I think that's where dual use might kind of fall apart.
Yeah, Tom and I were just talking backstage, like the Mira platform was meant to be a test bed for our technology, and we did a launch, and now we're selling more than we can build, basically, of the platform. So it was one example where dual use worked to our advantage, but not always.
A year ago, we would have said that that Mira is probably like Falcon 1. It developed the team, but we're probably not going to sell too many. And all of a sudden, we found out that's just really what the Space Force wants. So it's really worked out well.
Laura?
Yeah, so I think dual use in software is a little bit more nuanced. We've really focused on commercial entities for the first 4 years of operating Epsilon 3. And I think what we're seeing is the government is shifting the way it thinks about software. A lot of government potential customers that we've talked to, they want to try to build their own software. And the same thing has happened with a lot of our customers on the commercial side, but they've come back and said, we don't want to have anything to do with building software. Well, the government has had large teams of people that can dedicate to building software that frankly is not that great, and we've heard many, many complaints about it. But as we're seeing the government try to be more efficient, starting a couple months ago, they are potentially cutting some of the extra people that they have that may not be specifically dedicated to building software anymore. And so we're seeing a shift, and we're having a lot more conversations around the government starting to use software like Epsilon 3. And so I think through this year and next year, we'll see a big shift in how we're able to support government on the dual use side.
So dual use, in theory, makes a lot of sense, right? You build a commercial product, the government can then just take that off the production line and go use it for their purposes. They don't have to spend the money on rebuilding it, all the non-recurring engineering, et cetera. In the space industry, though, the reality of dual use, I think, is a lot more similar to what Tom described, right? Where you might go as a company, invest in something and build something up, and then the government will want to go use it. I think a lot of people, a lot of investors who may not be as familiar with the space industry sometimes think, oh, there's a long list of commercial customers that are pure play commercial in space, and then, oh, you'll do a little government stuff here or there. I think the reality of the situation is there's very, very few things that are pure play commercial in space. Almost everything, there's a couple of notable exceptions like Starlink and a couple others, but almost everything touches defense one way or another. Even something like Starlink has an adaptation called Star Shield that touches the government. So what I would just say is I think the reality is when you look at the space industry, right, the phrase dual use is always exciting, but even as Shahin has joked, there's a lot of these rinky-dinky startups that claim to be commercial only, and what you really got to do is look under the hood and say, who's actually paying for this at the end of the day? If you're an Earth observation company collecting all this data, you might go out and say, my biggest customers are hedge funds or insurance companies, but then you really look under the hood and it's NGA or NRO who's spending most of their money, government agencies, the IC, on a lot of this data. So what I would just say is if you're an investor in the room looking at this industry, like dual use is great in theory, but really look closely at these companies to understand where the flow of money is, not just at the first level, but one order deeper.
So we're hearing a lot about the new administration being very friendly to aerospace and defense and new companies in this realm. Have you noticed anything new or interesting with the incoming administration, Tom?
Yeah, I think the budget for space, spending on space is going to go way up. There's a lot of activity going on up there. It's not like people don't know like really what's going on up there. I don't know because I don't have a clearance yet, but you hear things. It's not like Ukraine where you can see what's going on. There's a lot of things happening in both LEO and in high orbit, and we need to continue to protect that domain and be able to match those adversaries. So I think military spending on space is going to go up a lot, and certainly the commercial use of space, LEO constellations and and more comms in space are going to continue to grow also.
Could you maybe elaborate on the strategic significance of these higher energy orbits? Who cares about the higher orbits? Why should we care? Why is there a national security aspect to it?
Well, probably the single most important single orbit is geosynchronous orbit, which is a 24-hour orbit. So you can cover the whole globe with 3 satellites because they can see each other and see all of the land surface on Earth. So it's a very important orbit. It's 36,000 kilometers, so it's roughly 50 to 100 times higher than LEO. So it takes a lot of energy to get up to that orbit, but it's a very important orbit. Pretty much, it's just a line around the equator that you can put satellites in. So there's a limited number of spots there, and those are their prized spots. So it needs to be protected, and there's just a lot of things going on up there. Like I think just last week there was an article about a Chinese spacecraft that was going around a Viasat or something, looking it over, and we don't really know what it's doing or can't do anything about it. So there's a lot of stuff happening up there.
Laura?
Yeah, I think there's going to be a renewed interest in government spending on defense, namely in what Tom was saying, Earth observation, weapon systems, so hypersonic, supersonic missiles, weapon systems. I've seen a lot of renewed interest. I have a friend who couldn't get funding a couple of years ago, and now he's got people knocking on his door every day. Basically, in the end, basically what we talked about is you want to have it and never need it, rather than the opposite, which is if you need it and you don't have any way to protect yourselves, we have a lot of adversaries coming for us, and we have to be able to get ahead of that. And like Ian said, it goes back to, you have to have the capability, but you also have to have the software to back that up. And so I think there will be a renewed interest in all of the aspects.
Tom and Laura are spot on with kind of, I think, the increased spend. I'll talk about this from a slightly different angle, which is something, Laura, you brought up, which is DOGE, right? Department of Government Efficiency. As mimetic or meme-worthy as that is, I do think there is something amazing about let's get the same capabilities for a whole lot less money, right? As a taxpayer, I don't know if anyone would disagree with getting more for less, right? It's great. The way that I built Apex and we run Apex is we are all about fast delivery, right? Don't wait around, wait for more things to come in. Upfront, transparent pricing, none of this cost plus bullshit, none of this craziness, right? Like, let's go straight for this is what it costs, this is what you get, and that's it. And our goal as a company is how do we enable the world's greatest primes, the greatest system integrators to be more efficient and to embrace DOGE and to be in a position where they could win more as spending goes up to deliver better quality capabilities for less money, faster.
So we wouldn't have a panel today if we didn't talk about AI. So I'd love to hear how each of you feel or expect AI to impact your businesses. Tom.
Yeah, we use AI tools, of course. Right now we don't generate enough data to be an AI developer. We don't use large language models. Perhaps we'll use some machine learning for data analysis and things like that, like we did at SpaceX. But I think recently Elon even said even SpaceX doesn't develop AI. They use AI tools. We've done generative design of a spacecraft chassis to 3D print and did analysis of it and came up with a really cool looking chassis that looked pretty organic, kind of looked like tree roots growing around, or bones, yeah. And ultimately, we use that shape to make a machined chassis, and the machine chassis was actually lighter because the strength of the material is higher. So, but it did inform us like where the load paths were and where to put the material. So I think we're getting close to doing generative design of a spacecraft. Certainly, we're using generative design for circuit layouts and things like that, but it's only increasing all the time, and the tools certainly are getting smarter. I was using Grok 3 the other day just to see how smart it was, and I gave it this basically draining a nitrous oxide tank under self-pressurization. So it's kind of like you're your barbecue, like your propane on your barbecue. As you drain that fast, the tank gets cold. So I asked it, I said, if I'm draining a certain flow rate of propellant out of a tank, and I have another circuit that's pumping liquid and vaporizing it in a heat exchanger, putting it back into the tank, does it make more sense to put it into the top of the tank as gas or bubble it through the bottom of the tank? And it gave me an answer to put it in the top. And then I said, make a chart showing that, I gave it some numbers and said, plot this tank, and it did it wrong. It came up with the wrong answer, so I said, hey, you're missing the mass of the vapor. You're only taking into account the mass of the liquid. Fix that. So it did through, oh, you're right, did all the things, and came out again, forgot about the vapor mass. If it was an intern, I would fire it. So AI is not there yet. It's getting better every day. I think to use it, you better understand the problem because it hallucinates and it'll give you, especially on pretty hard engineering problems, it's almost always wrong. But it certainly is useful, and it's certainly getting better all the time.
Yeah, so we're storing a lot of data for our customers, and they all ask us what we're doing on the AI front. And my question back is, what do you want us to do? And they're not really sure. They just know that we should be doing something in AI. So I tell them, we're storing data on how long things take, how many issues you're tracking on your hardware builds. How do you want me to display that? And does it actually require AI? Because a lot of the problems they want us to solve don't necessarily require AI. So what we're doing right now is we are allowing our customers to generate their operational documentation using AI and allowing them to upload, hey, here's what my design documentation looks like. Here's how I should operate our vehicle. And then what they have to do is they have to train it because it's not going to be right, like Tom said. It's not right, so they will have to edit it. So it's not quite there yet, but we are attacking the problem, it's not going to solve the problem 100%.
And then real quick, I'll just add, completely agree with Tom and Laura. We use it as an enabler for our engineers, right? So we have a lot of software engineers. They love it because it auto-completes. It helps them. But the one thing that I think, Tom, you talked about is like the hard engineering problems, it still gets wrong most of the time. And if it gets it right once, but it's getting it wrong most of the time, like you don't want to trust it. So I am super hopeful for where it goes and how we'll do that. I will say it's definitely saving us time and money right now, just our employees are more efficient. But is it designing the satellite for us, and is it doing that? I would not trust it. I wouldn't trust anyone who says it's going to do that in full today. Eventually, we'll see.
Awesome. Well, with that, thank you, audience. Thank you, panel. You guys are fantastic.